are saying about the reinforced concrete slab design. You're here. So from new select document, then you come to reinforced concrete slab design. Yeah. You're there? Hello, engineer. Hello?
RC slab design.
Yeah, then you come to calculate.
Hello? Yes, it's where I am now.
So after clicking calculate, it is going to bring you the tab where you're going to set all the parameters you want. Yeah.
Okay.
So the national annex, we are using United Kingdom as before. So for another country, they can select a different national annex. Then the name, you can give it a name. Mine is
Annex.
roof tank slab.
United Kingdom.
Yeah. So you can give it a reference name, maybe where you can remember, maybe roof tank slab, right? Then the overall depth, I said we assume 200, then we shall design and check.
I just put the roof what?
Roof tank slab as the reference name.
Assume how many?
Assume 200.
Hello?
Assume 200 millimeter.
Engineer?
Yeah, I'm getting you. Assume 200 millimeter. Then type of slab,
Okay.
we said it will be a two-way because
That one is done.
the type of slab I said it will be a two-way because the length and width they are
It is
almost
done. It's 200 millimeters.
yeah, the length and width they are almost the same. The type of slab will be a two-way spanning slab.
Length and width.
Yeah, length and width are almost the same.
Two-way.
Yeah, two-way because as per my drawing here,
Okay.
as me show you by my drawing here, we shall see the conditions.
Then restrain edges.
First, what I show you, I want to show you the spans.
Yeah. Yeah.
So the roof slab you can see because I have to pick the biggest span, my worst case span, right? So in this case, it is this one here, okay? This place here. So you can check the length. The length. Let me change let me change this font style to one that is a bit visible. This is AutoCAD.
Sorry?
I wanted to show you the span that it is almost the same. When you get the length divide the width and it is less than 2, then that is a two-way spanning slab. You get it, eh? This is my biggest
Yes.
span. You see the length is
It
3.14.
should be less than 2, eh?
Yeah, this is 3.14. Are you seeing it? Then the width is 3.69, right? 3.69 divided by 3.14 is less than 2 automatically, right? Yeah?
Yes.
So it qualifies to be a two-way spanning slab. I think that is clear. So go back to TEDS. The edges are restrained, yes, because it is supported on beams and it is cast monolithically, right? It is cast together with the beam, so the edges are restrained. Yeah. So we go in this tab of define slab geometry, and loading. Engineer. Hello?
Mm.
So we are saying you go to on the
We
loading
were on the what? The
geometry.
size of the slab.
Yeah,
It was 3.1.
the width and length.
Yeah.
The width. The width was 3.1 and the length was 3.6.
Uh,
So 3.6 divided by 3.1 is less than 2.
yes.
This makes the slab two-way spanning slab. It means the loading can go on either side of the length and width.
Mm.
So when you go back to our slab, uh, we said the edges are restrained because the beams and the slab they are cast monolithically.
Okay.
So we go to define geometry and loading, right?
Mm.
You click on that red panel. So our permanent load we had it as 6.15,
6.15.
and our calistic variable load we had it as 7.94 because of the tanks
7.94.
94. The shorter span is 3.14.
Shorter effective
3
span.
141
That is
millimeter.
3.1.
41.
That is LX.
Yeah. Then LY the longer span is 3690.
690.
Now we go on the support conditions.
Yes.
Support conditions will come back to our slab.
Mm.
This slab it has it has a slab on the upper side, right?
Yes.
It has a slab on the right side.
Mm.
It has a slab on the lower side. Yeah.
Yes.
But on this side there is no slab because it's the staircase. Yeah.
Yes.
So it means this slab is continuous on the three sides, and only one side is
Yeah.
it is discontinuous, right?
Yes.
So we come and check it. And on the support conditions, they are supported on 4 edge continuous. No, that's not right, right?
3 edges.
So it is supported 3 edges. It has a one short edge. It is one long edge is discontinuous. It means the rest are continuous, right?
Continuous. Yes.
One long edge discontinuous.
Okay.
Now, where do we want our outer? It is always preferable to have your outer reinforcement span in the shortest span direction.
The outer. What do you mean? The one on
The top one and
the
bottom
one
one.
on top.
Yeah, top
Mm.
one and bottom. It is always better for them to span in the short direction. Yeah.
What do you mean by top and bottom?
Top and bottom. What I mean, I don't have a slab section, but
Okay. There is always a longer and a shorter direction.
yeah, there's always a
The
longer and
one which
shorter
is going to
direction.
be on the one which is going to be on top
Mm.
should be
For
on
example,
the longer direction.
no, the top one should be on the shorter direction because when it is spanning the shorter direction, it is more strong. So the top
Uh,
we normally design for the top and the most top and the most bottom. We call they are our load bearing. Yeah.
yes.
The other ones, bottom two and top two, are supposed to be distribution.
Okay.
So it was preferably the top bar to span in the short direction.
Shorter direction.
Yeah, it's just a principle. Though it is not a.
So it is like a mat. Eh?
Yeah, it is a mat. It has to be a mat.
It is a mat. Eh?
Is a mat.
Okay. So the one on top, which is the compression side, should be on the shutter direction.
Yeah. And the one on the bottom, which is the tension side, has to also be in the shutter span direction.
Okay.
So we say okay. So we come and check these parameters where they are correct. The maximum aggregate side has to be 20. The fire resistance, we can keep it at 1 hour, that is 60 minutes. Concrete cover.
Wait a bit.
Mm.
Where we have just put, I've tried to click OK. It is bringing me, please input a positive value in millimeters of.
Yeah, you check here. Did
Okay,
you put
okay,
them
okay.
in millimeter or you put them in meter? They are in
Okay,
millimeter.
I've got.
3141 for the short side, 3690 for the long one.
Mm,
So click OK.
okay.
You're done?
Yes, I'm done.
Fire resistance, we keep it at 1 hour, that's 60 minutes. Yeah.
Mm, mm,
Comfort reinforcement, we can make it 25,
25.
both bottom and below.
Mm,
Concrete strength, we can even make it 1620.
1620.
So after that, we come to our reinforcement. This red
So this
reinforcement,
one, the reinforcement yield strength, I've reduced to 460.
exactly, thank you, 460, because
Okay.
sometimes on market we don't have 500.
Okay.
So the reinforcement details, are you there?
It is. I'm there.
So you see they have T8 at 200, T8 at 200, T10 at 200, T8. So I prefer using, you see, they don't give you a full, they just give you mid span and support, right?
It's fun.
Yeah, you see, they are saying short span, mid span area required is 217. Yeah,
Mm,
area provided is 251, right?
yes.
So yeah, they are saying use same area at discontinuous support. Yeah, I prefer using same area at support to avoid confusion during construction.
Mm,
So long span rules bar, they are saying 8 millimeter bar at 200 spacing. Same, even at support, right?
mm,
So since they are saying it is tick, fine, we can first leave it at there. We say okay.
yes.
Because you can't put a bar minimum than 8 millimeter, right?
Mm,
When we say okay, we come to this preview results. You're seeing that
click
checkbox?
on it. Yes.
You check now whether it is tick. It is tick.
Yeah.
Then you also check in the long span direction.
Short span, long span.
It is also tick.
All also tick tick. Mm,
So it means the spans were not that long, eh?
mm,
And the loading anyway was 3.3 meter a 200 millimeter span is a and 200 millimeter thick is not that big deal.
mm,
I'll go back to short span. I think it is okay. So you assume our slab was 150, right?
yes.
Because you have to always design something which is economical to the west and safe. So
Okay.
you check 150 and see whether the results change a bit. The results are still normal.
Mm,
Yeah. Until you get maybe check 100. We assume 100 and see.
100.
You see, when you put 100, you get some reds. Yeah.
On the shorter span, I'm not getting it.
No, 100 slab overall slab lift.
It has. I think it was still loading.
So you see, you cannot have 100 millimeter. Yeah.
Mm,
So the smallest you can have is 150.
and 50.
Because at 150 at least It will not produce leads.
Mm.
Yeah.
Yes.
Yeah. So now there you can decide as an engineer which one is the more safe for you. Yeah.
Mm.
Is the quality
And
control okay?
economical.
Yeah.
Mm.
For villages where there's no quality control, maybe the concrete even doesn't reach C20. So you can select C12 15. Yeah.
Mm.
So and check whether it still passes. Yeah. You get it?
Yes.
I think the loading will do it properly. Yeah. And check again whether it still passes. And at the end of the day, you have to make sure you achieve the three factors. The building is safe, it is economical, and it is
Economical.
buildable. Yeah.
Mm.
It means
Yes.
that worst case scenario, our slab of 150 can work. We still 8 at 200. Yeah.
Mm.
If all the detailing and what is done properly, but because you always have to add your own factors safety as an engineer, you can decide to increase the bar size to 10 at least,
Yes.
because 8 is very small. For structure
Mm.
purposes, we can increase it at 10 at 200 spacing. Now there are cases when you have a simply supported slab. Yeah,
Mm.
it's not cast monolithically, like the edges are not restrained.
Mm.
uh, so you could check the difference. Hmm? You realize if the edges are not restrained, here they show that 30 10 passes, but you see the deflection fails. Eh? Hello?
Then, yes.
Yeah, for cases where the edges are not restrained, eh?
Mm.
They are showing you the slab will fail in deflection. Eh? And in most cases, when a slab is failing in deflection, it means you need to add the depth. Yeah?
Yes.
So maybe you can increase it to 175, because those cases are there when the slab is just simply supported and is not cast monolithically. Maybe they come and put it later when the beams are already there. Yeah?
Mm.
Maybe they had not planned for a roof tank slab. Now they are coming to fix it on top of a ring beam. So you will realize that if it is the edges are not restrained, you have to increase your slab thickness to 175. So this is
Okay.
how we play around with the solid slab design.
But there, I did not see where you went.
For
Changing the support condition.
no, here where you're seeing the restrained edges. At first it was ticked, yeah.
Mm.
Then I unticked it.
Yes.
You get it? So
Mm.
when you untick it, you have to go back and change all the parameters.
Antique, you have to go to geometry again.
And change the parameters and confirm it is okay. Then you go to reinforcement and also confirm that the details are okay. Yeah.
Mm.
Then you can come and preview the results.
Okay.
If there's some red and the deflection is failing, you change the depth. That's why I changed it to 175.
Deflection ratio was failing.
Yeah, so you can change the depth to 175. If it's still failing, you can change it to 200. If you see the depth is
Mm.
not solving the problem, you can change the reinforcement size from
Okay.
T10 now to T12.
Okay.
If you're done, you just finish.
But again, that this solid slab is sweet.
Yeah, it is sweet. It is easy to design.
Mm.
So when you're done, you just say finish, and the TEDs can bring you an output showing you all the members what they are passing,
Okay.
and even down to details for you, and shows you how you're going to arrange your bars. Which one is B1,
Mm.
which one is T-top, yeah. But the detailing is not good, because now you don't need to add two bars, so just one bar is enough.
Mm.
Yeah, that's a solid slab design.